March 14th, 1943, AO347 hours. North Atlantic, 380 miles southwest of Iceland. The USS Benson shuddered as another depth charge detonated 200 feet below the surface, sending a column of white water 40 feet into the freezing air. 19-year-old Seaman First Class Tommy Riggs pressed his body flat against the aft deck plating, feeling the vibration travel through the steel and into his chest cavity like a second heartbeat. His hands, already numb despite the wool gloves, gripped a 9-inch crescent wrench and a roll of plumber's tape he'd stolen from the forward head 3 hours earlier. 60 feet behind him, the portside depth charge rack had jammed for the fourth time in 2 hours, its release mechanism frozen by a design flaw that had plagued Fletcher-class destroyers since their commission 18 months ago. The rack held 8 600-pound Mark IX depth charges, each packed with 200 pounds of Torpex explosive, powerful enough to crush a submarine's pressure hull at 300 feet. 4 of those charges should have been in the water already, hunting the German U-boat that had just put a torpedo through the Liberty ship Thomas McKean, sending her to the bottom with 47 merchant sailors and 8,000 tons of aviation fuel bound for Britain. Instead, they sat uselessly in their racks because a 12-cent spring in the release mechanism had warped under repeated exposure to salt spray and sub-zero temperatures. Tommy had been watching that spring fail progressively over the past 6 days, ever since the Benson left Halifax as convoy escort. He'd warned the chief bosun's mate about it on March 10th. The chief had told him to mind his welding equipment and let the Navy's ordnance specialists handle weapon systems. Now the chief was below decks coordinating damage control, while Tommy, the former Pennsylvania shipyard welder who'd lied about his age to enlist at 17, was the only man topside who understood what needed to happen in the next 90 seconds. The Benson's captain, Commander James Warwick, had the destroyer heeled over in a hard turn, trying to position for another depth charge run over the U-boat's calculated position. The submarine was down there, wounded, but alive, after taking glancing damage from the first pattern. Sonar had her at bearing 187 degrees, depth estimated 280 feet, moving at 4 knots. She was trying to escape into the thermal layers where sonar couldn't track her. If she made it, she'd surface after dark and finish off 2 more merchant ships before Allied escorts could respond. The convoy had already lost 3 vessels in the past 12 hours to what the British Admiralty called Wolfpack Hartung, 6 U-boats operating in coordinated attack patterns across the North Atlantic shipping lanes. Tommy's modification was embarrassingly simple, the kind of fix that would make Navy engineers in Washington wonder why they hadn't thought of it themselves. He'd noticed the problem 2 weeks ago in Halifax during a routine maintenance inspection. The depth charge release mechanism worked on a spring-loaded lever system. Pull the handle, compress the spring, release the catch, and gravity rolled the 600-pound charge off the rack into the ocean. Textbook mechanical engineering, except the Navy had specified a coil spring with a 0.048-inch wire diameter when the application actually needed 0.063 inches. The thinner spring worked fine in warm water or short deployments, but 6 days in the North Atlantic with temperatures hovering around 28 degrees Fahrenheit had caused the metal to lose its temper. The spring was compressing when pulled, but not returning to position with enough force to reset the catch mechanism. Tommy had solved it with parts that cost $2.83 at any hardware store in America. 2 47-cent zinc-plated washers, thickness 0.125 inches. 1 roll of plumber's Teflon tape, 78 cents. 1 split-ring lock washer from the machine shop, free. The modification took 11 minutes to install and required no specialized tools beyond a wrench and screwdriver. He'd done it first on the starboard rack during the midnight watch on March 12th, working by flashlight while the rest of the crew slept. The washer shims increased spring compression by exactly 0.250 inches, enough to compensate for the metal fatigue. The Teflon tape wrapped around the spring coils reduced friction and prevented moisture intrusion. The lock washer prevented the adjustment nut from backing off under vibration. It was the kind of improvisation he'd done 1,000 times in the Philadelphia Navy Yard, when production quotas meant you couldn't wait for the correct parts to arrive. The first test came at 1420 hours on March 13th, when a Focke-Wulf Condor maritime patrol bomber tried to attack the convoy. The Benson had maneuvered to deploy a defensive depth charge pattern as anti-aircraft disruption, a controversial tactic that used underwater explosions to throw up spray and confuse attacking aircraft. Tommy's modified starboard rack had worked flawlessly, releasing all 8 charges in a perfect 40-second sequence. The port rack, still using the factory spring, had jammed after 3 charges and required manual release using a pry bar and sledgehammer. Now, with an actual U-boat contact, the port rack was doing it again, and they were out of time. "Riggs, what the hell are you doing back there?" Lieutenant Junior Grade Morrison's voice cut through the wind, barely audible over the destroyer's engines, as they wound up to 28 knots. Morrison was the gunnery officer, a 24-year-old Annapolis graduate who'd been aboard for 6 weeks and still thought everything worked the way it did in training manuals. "Get forward before you're washed overboard." Tommy ignored him. He had the access panel off the release mechanism, exposing the spring assembly. Just like the starboard side 2 days ago, the spring was compressed, but the catch wasn't resetting. The solution was in his pocket. He'd prepared 6 sets of shims and washers after the first successful modification, keeping them wrapped in oilcloth against the salt air. His fingers felt thick and clumsy as he worked the old spring assembly loose. 30 seconds to remove the retaining nut. Another 45 to fit the washers and tape the spring coils. The Benson was coming around to her attack heading, the sonar contact getting sharper as range decreased to 800 yards. In the Combat Information Center below, the fire control team was calculating drop patterns, timing sequences, trying to put 4,800 pounds of high explosive in the exact 3-dimensional space where a German U-boat would be 17 seconds after the charges hit the water. The modification went in cleanly. Tommy tightened the retaining nut, added the lock washer, tested the lever. The spring compressed with firm, even resistance, and snapped back to position with authority. The catch mechanism reset with a solid click he could feel through his gloves. 60 seconds of work. The depth charge rack was armed and operational. Contact bearing 185, range 600 yards. The report from the sound room crackled over the loudspeakers. Tommy scrambled back to the safety rail as the Benson's stern began to rise, the destroyer heeling into the attack run. Commander Warwick was taking her in at full speed, intent on dropping a full pattern directly over the submarine's position. This was the knife fight range, where destroyer captains earned their reputation or got their ships sunk, close enough that a lucky torpedo could cut the Benson in half, close enough that the depth charges would shake their own ship hard enough to crack instrument dials and shatter light bulbs throughout the vessel. "Prepare to release depth charges," Morrison's voice again, steadier now, falling into the rhythm of the attack. "Port and starboard racks, full pattern." Tommy watched from his position at the rail as the petty officer at the port rack pulled the release handle. The mechanism he'd just modified worked exactly as designed, the spring compressing and resetting smoothly as the first 600-pound charge rolled off the rack and into the Atlantic. 3 seconds later, the second charge followed, then the third. The entire 8-charge pattern deployed in 35 seconds, each one tumbling off the stern with mechanical precision, while the Benson's propellers churned the water white, accelerating away from the killing zone. The charges were set for detonation at 250 feet, calculated to bracket the submarine's depth. Tommy counted down in his head, 28, 29, 30 seconds. The first explosion erupted 300 yards astern, a dome of white water rising 50 feet and collapsing back on itself. Then the second, third, fourth. the entire pattern detonating in a sequence that turned 200 yards of ocean into a cauldron of compressed water and explosive force that could crush a submarine's hull like a beer can under a boot heel. The Benson shuddered with each explosion, violent enough that Tommy had to grab the rail to keep from being thrown to the deck. The noise was beyond sound, a physical pressure that felt like it was pushing his eyeballs back into his skull. Sonar contact lost. The report from below sounded almost disappointed. That could mean the U-boat was destroyed, or it could mean she'd found a thermal layer and slipped away. There was no way to know for certain without visual confirmation. Debris, oil slick, bodies. Sometimes submarines sank and left no trace except the absence of their presence on sonar screens. Commander Warwick ordered the Benson into a slow search pattern, circling the attack zone while lookouts scanned for wreckage. 10 minutes passed, 20. The ocean gave up nothing. The U-boat contact was gone, either destroyed or escaped, and convoy SC-122 was still 11 hours from the relative safety of aircraft coverage from Iceland. The merchant ships were scattered across 8 square miles of ocean, struggling to reform their defensive box while 3 escorts prowled the perimeter looking for more submarines. Tommy was checking the port depth charge rack, reloading it with fresh charges from the reserve magazine, when Lieutenant Morrison appeared at his shoulder. The gunnery officer's face was tight with the kind of anger that comes from having been wrong about something important. "That modification you made," Morrison said, his voice barely carrying over the wind. "The one I specifically told you not to make without authorization. You want to explain why you disobeyed a direct order?" Tommy looked at him for a long moment, then back at the rack. The spring mechanism was still working smoothly, resetting after each charge with the precise action that had been missing for 6 days. 8 more depth charges were ready to deploy, and given the tactical situation, they'd probably need them before dawn. "Permission to speak freely, sir?" "Denied. Report to the XO's stateroom at 800 hours. We'll discuss your unauthorized modifications to Navy equipment." Morrison turned and walked forward, leaving Tommy alone with the reloaded rack and the certain knowledge that some officers would rather lose a war than admit an enlisted man had solved a problem they couldn't. But that was a problem for AO 800 hours. Right now, at 0419 on March 14, 1943, in the middle of the North Atlantic, Tommy Riggs had 7 hours and 41 minutes before he had to explain to the executive officer why he'd saved the ship. The story of how a 47-cent washer became one of the most important modifications in the Battle of the Atlantic had started 3 weeks earlier in Halifax, and it had started with the kind of accident that only happens when someone is paying attention to the wrong thing at exactly the right moment. Tommy had been assigned to the Benson in February as part of a shipyard maintenance crew, specialists sent to address recurring problems with the Fletcher-class destroyers during their brief port calls. He was supposed to be welding damaged hull plates and checking propeller shaft alignment, but on February 23rd, during a routine inspection of the aft deck, he'd noticed something that the ship's regular crew had stopped seeing because they saw it every day. The port side depth charge rack had a mark on the deck plating beneath it, a half circle of abraded paint about 3 inches wide, exactly where the release lever would strike if it was pulled too hard. Tommy had seen similar marks in the shipyard, on equipment that was being operated beyond its design parameters. Operators pulling harder because the mechanism wasn't responding correctly, using force to compensate for mechanical failure. He'd pulled the access panel and found the spring assembly showing signs of fatigue, microscopic cracks in the coil surface, discoloration from repeated compression cycling, a loss of tension that meant the spring was no longer returning to full extension. Standard maintenance procedure called for spring replacement, but replacement springs were back-ordered from the manufacturer with a 6 to 8 week delivery time. The shipyard solution would have been to machine a new spring from stock material, but that required specifications that Tommy didn't have, and a machine shop that was already running 3 shifts, trying to keep up with destroyer production. So he'd done what he'd done 100 times before in civilian life, looked at the mechanical problem, analyzed what was actually failing, and fixed it with parts that were immediately available. The washer shims increased pre-compression, compensating for the spring's loss of tension. The Teflon tape reduced friction and prevented the saltwater corrosion that accelerated metal fatigue. The lock washer kept everything from vibrating loose. Total parts cost, $283s. Total installation time, 11 minutes. Total engineering sophistication, roughly equivalent to fixing a screen door spring. He'd done the starboard rack first as a test, working during his lunch break on February 24th, while the rest of the maintenance crew was eating in the enlisted mess. The modification worked perfectly. The release mechanism operated smoothly, reset reliably, showed no signs of binding or hesitation. He'd planned to do the port rack next, but the Benson had gotten underway orders that afternoon, heading out for convoy escort duty before he could finish. Tommy had mentioned it to the bosun's mate, who'd promised to pass it along to the ship's engineering officer. Whether that conversation had actually happened was unclear, but the fact remained that the Benson had left Halifax with one modified depth charge rack that worked flawlessly and one factory-standard rack that was progressively failing. The failure had accelerated exactly as Tommy had predicted. The first jam occurred on March 8th during a routine drill, the second on March 11th, the third this morning during the Focke-Wulf attack. Each failure forced the crew to manually release the charges using pry bars and sledgehammers, a process that took 3 minutes per charge instead of the designed 4 seconds. In anti-submarine warfare, where the difference between a successful attack and a miss could be measured in seconds, that delay was the difference between killing a U-boat and letting it escape to sink more ships. Now, standing in the pre-dawn darkness, with his hands still shaking from adrenaline and cold, Tommy understood that he'd done something that would either get him court-martialed or commended, depending on whether the U-boat they'd just attacked turned out to be confirmed dead. The answer came at 05:23 hours, when a lookout spotted debris surfacing 400 yards off the port beam. Oil slick first, a rainbow sheen spreading across the black water, then wooden planking shattered and splintered, then the pieces that confirmed the kill, a life vest with German markings, a seat cushion from a U-boat control room, and finally, the thing that brought a savage cheer from the Benson's crew, a section of pressure hull plating with the number U-527 stenciled in white paint. Type Yangtze U-boat, commissioned in October 1942, operating out of Lorient in occupied France. She'd been hunting in the North Atlantic for 6 weeks, credited with sinking 4 merchant ships totaling 28,000 tons. The Benson's depth charge pattern had caught her in shallow water, the explosions crushing her pressure hull and sending her down with all 53 hands aboard. Commander Warwick made the announcement over the ship's intercom at 0547 hours, his voice steady despite the exhaustion that made him sound 20 years older than his actual 34. "This is the captain. We have confirmed kill on a German submarine. Well done to all hands, particularly to Seaman Riggs, whose unauthorized but highly effective modification to our depth charge rack made this kill possible." Tommy was summoned to the bridge at 06:15 hours, where he found not just the captain, but also the executive officer, the gunnery officer Morrison, the chief engineer, and the bosun's mate who'd told him to mind his own business 6 days ago. The mood in the bridge house was complex. Pride in the kill mixed with embarrassment that it had taken an enlisted shipyard welder to solve a problem that had plagued the entire Fletcher-class destroyer fleet for 18 months. "Seaman Riggs," Commander Warwick began, and Tommy snapped to attention despite his exhaustion. "You're going to write down exactly what you did to fix that depth charge rack. Every part, every measurement, every step of the installation process. The chief engineer will review it, and if it checks out mechanically, we're going to send it to DESDIV 23 headquarters, with a recommendation that every destroyer in the Atlantic Fleet adopt this modification immediately. The chief engineer, Lieutenant Commander Peters, looked like he'd swallowed something bitter. The modification is mechanically sound, he admitted, actually more robust than the factory specification. I've been reviewing the spring assembly, and I believe Seaman Riggs has identified a fundamental design flaw in the release mechanism. His solution is crude but effective. Crude works, Warwick said, especially when crude keeps us from having jammed depth charge racks in the middle of a U-boat attack. Morrison, you had concerns about unauthorized modifications? Lieutenant Morrison, to his credit, looked directly at Tommy when he answered. I was wrong, sir. The modification was necessary and properly executed. I apologize to Seaman Riggs for not recognizing the problem's urgency. The meeting lasted another 20 minutes, with Tommy explaining the mechanical principles, demonstrating the installation process, and answering technical questions from the chief engineer about stress loads and material fatigue. By 0645 hours, he had the captain's approval to modify every depth charge rack on the Benson, and a written commendation that would be forwarded to Destroyer Division 23 Theoretistation 3 headquarters in Halifax. But the real test came 3 hours later when the Benson's radio operator received a flash message from the convoy commodore. U-boat contact, multiple signatures, bearing 165 degrees at 12 miles. Wolfpack Hartung was making another coordinated attack run, and this time they were bringing at least 4 submarines against the scattered merchant ships. The Benson and her sister destroyer USS Hobson wheeled away from the convoy, racing toward the contact at 32 knots, while the merchant ships turned away and tried to scatter. The mathematics of naval warfare were brutally simple. 2 destroyers, 8 submarines. If the U-boats could coordinate their attack, they'd overwhelm the escorts and sink 6 to 8 merchant ships before dawn, unless the destroyers could kill enough submarines fast enough to break up the attack pattern. Tommy was back at his position by the aft depth charge racks, both of them now modified with his washer and tape fix, both of them loaded with fresh charges. The Benson was steaming toward a knife fight where mechanical reliability would matter more than courage or skill. If the depth charge racks jammed, ships would die. If they worked as designed, there was a chance, a small chance, but a real one, that an American destroyer and a Philadelphia shipyard welder could turn the Battle of the Atlantic one depth charge at a time. At 0944 hours, sonar reported the first contact at 3,800 yards and closing. Commander Warwick ordered flank speed and bent the Benson into her attack run, the destroyer's bow rising as her 4 boilers drove her toward 35 knots. Tommy gripped the safety rail and waited for the order to release depth charges, knowing that in about 90 seconds he'd find out whether a 47-cent washer could really change the course of a war. The first submarine appeared on sonar at bearing 163, depth 220 feet, speed 6 knots. The second contact merged on the screen 45 seconds later, bearing 168, depth 195 feet. They were hunting as a team, one boat drawing the destroyer's attack, while the other maneuvered for a torpedo shot. Classic Wolfpack tactics, and they'd sunk hundreds of thousands of tons of Allied shipping using exactly this approach. What they hadn't planned for was a destroyer whose depth charge racks could deploy full patterns in under 40 seconds, giving the attacking vessel enough time to hit both submarines before either could escape or counterattack. Tommy's hands were steady now, the cold forgotten, the fatigue pushed aside by the clarity that comes from knowing exactly what needs to happen next. The Benson was going into the fight with every mechanical advantage Tommy could give her, and whether that would be enough was about to be decided by physics, timing, and the question of whether German submarine captains had ever encountered an American destroyer that could drop 16 depth charges in 90 seconds across 2 different target coordinates. The answer, Tommy was about to discover, was no. And that was going to change everything. The Benson's sonar operator, Petty Officer Second Class Raymond Chen, had been tracking submarines in the North Atlantic for 11 months, long enough to recognize when U-boat commanders were making a mistake. At 0946 hours on March 14, 1943, he was watching two German submarines make a fatal tactical error, and the strange thing was that they didn't even know it yet. "Captain, both contacts holding steady course," Chen reported, his voice carrying the practiced calm of a man who'd learned to separate fear from function. "Lead boat at bearing 162, range 2,200 yards, depth 215 feet. Trailing boat at bearing 169, range 2,600 yards, depth 190 feet. They're setting up a classic hammer and anvil, sir." Commander Warwick understood immediately. The lead U-boat would draw the Benson's attack, absorbing the depth charge pattern while the trailing submarine maneuvered into firing position for a torpedo spread. It was textbook Wolfpack doctrine, was Kekbot Motdaktarov, and it had worked brilliantly against British corvettes and older American destroyers, whose depth charge racks could only deploy 4 to 6 charges per run, with significant delays between releases. The German commanders had calculated their tactics based on the assumption that the Benson would need at least 4 minutes to reload and reposition for a second attack run. That assumption was about to cost them both submarines and 106 German sailors. "Mr. Morrison," Warwick said, his hand steady on the bridge railing as the Benson accelerated through 33 knots. "Prepare full patterns on both racks. We're going to hit the lead boat on the first pass, then come hard to starboard and drop on the trailer before he knows what happened." Morrison's eyes widened slightly. The maneuver Warwick was describing required perfect timing and, more importantly, depth charge racks that could deploy full 8-charge patterns in under 40 seconds. "Sir, if the racks jam—" "They won't," Warwick interrupted. "Riggs fixed them. Both racks tested clean at 0700 hours. We're going to put 16 charges in the water across 2 target coordinates in under 3 minutes. The Germans won't be expecting that because no destroyer in the Atlantic Fleet can do it, except we can now." At the aft deck, Tommy had both racks loaded and armed, the modified release mechanisms tested and ready. He'd done one final check at 09 PM hours, personally verifying that the washer shims were properly seated, the Teflon tape was intact, and the lock washers were torqued to specification. The port rack that had jammed 4 times in the past week now operated with the same smooth precision as the starboard rack he'd modified 2 weeks ago. Both mechanisms reset with that solid metallic click that meant the springs were maintaining proper tension despite the salt spray, the vibration, and the sub-zero temperatures. The Benson heeled into her attack run, the deck canting at a 12-degree angle as Warwick pushed the destroyer through a turn that brought her bearing directly over the lead submarine's calculated position. Tommy could see the wake streaming behind them, white water churned by the propellers spinning at 280 RPM, driving the Fletcher-class destroyer toward her designed top speed of 38 knots. At this speed, the Benson was burning 750 gallons of fuel oil per hour. But fuel economy didn't matter when you had 2 U-boats in firing position. "Range 800 yards, Chen's voice crackled over the loudspeaker. "Contact bearing 161, holding depth at 210 feet, speed increasing to 8 knots. He knows we're coming." The submarine commander was doing exactly what Tommy would have done in his position, driving deeper and faster, trying to get below the depth charge's effective killing radius, or into a thermal layer where sonar couldn't track. But he was running out of ocean. The North Atlantic sea floor at this position was 6,400 feet down, but the U-boat's crush depth was only 750 feet, and that was with a brand new pressure hull. Most Type Wanksee boats operating in the Atlantic for more than a few months had stress fractures and compromised welds that reduced safe diving depth to 600 feet or less. The German captain could run deep or run fast, but not both. "Steady as she goes," Warwick ordered. "Fire control, set depth charges for 220 feet, full pattern, 3-second intervals." The Benson crossed over the target at exactly 0948 hours and 23 seconds. Tommy didn't wait for Morrison's order. He was already at the port rack release lever, and the moment he saw the range counter hit 0, he pulled. The modified mechanism worked flawlessly. The spring compressed smoothly, the catch released with precise timing, and the first 600-pound Mark 9 depth charge rolled off the rack and tumbled into the Atlantic 42 feet below. 3 seconds later, the second charge followed. Then the third, fourth, fifth. The entire 8-charge pattern deploying with mechanical precision, while the Benson accelerated away from the killing zone at 34 knots. Tommy was already moving to the starboard rack when the first explosion erupted 300 yards astern. The depth charge had reached 220 feet and detonated, creating a pressure wave that traveled through water at 4,800 feet per second with enough force to buckle steel plating at 100 yards. The second explosion followed 3 seconds later, then the third, the entire pattern creating an overlapping field of explosive force that turned 250 yards of ocean into a zone where no submarine could survive. The Benson shuddered with each detonation, the shock waves transmitting through the hull and making the deck plating vibrate under Tommy's boots. But Warwick wasn't waiting to assess damage. The destroyer was already heeling hard to starboard, coming around on a new bearing that would bring her over the second submarine's position in 87 seconds. "Second contact breaking deep," Chen reported. "Bearing 172, depth 240 feet and descending, speed 12 knots. He's running, Captain." "Stay with him," Warwick ordered. "Mr. Morrison, reload port rack and prepare starboard rack for immediate release. I want that second pattern in the water before he reaches 300 feet." Tommy was already hauling fresh depth charges from the reserve magazine, working with 2 other sailors to reload the port rack. Each charge weighed 600 pounds, required 2 men to maneuver it into position on the rack, and needed to be properly secured with a safety pin before it was armed for release. Standard reload time for an 8-charge rack was 12 minutes. Tommy and his crew did it in 6 minutes and 40 seconds. Working with the kind of desperate efficiency that comes from knowing that 400 yards away, a German submarine was diving towards safety while you raced to stop it. The starboard rack was already armed and ready. Warwick brought the Benson screaming over the second submarine's position at 0951 hours, the destroyer doing 35 knots and vibrating so hard that instruments were shaking loose from their mounts in the Combat Information Center. "Fire control solution locked," Morrison shouted. "Range 200 yards, bearing 174, target depth 265 feet and holding." Tommy pulled the starboard rack release, and once again, the modified mechanism performed exactly as designed. 8 depth charges deployed in 35 seconds, set for detonation at 280 feet to bracket the submarine's depth. The Benson accelerated clear while behind her, 4,800 pounds of high explosive was falling toward a U-boat that had nowhere left to run. The first 4 charges detonated in sequence at 280 feet, creating pressure waves that converged on the submarine from multiple angles. The 5th charge caught the U-boat's stern section, buckling the pressure hull and flooding the aft torpedo room in less than 8 seconds. The 6th charge detonated directly above the submarine's control room, crushing the conning tower and killing everyone inside instantly. The 7th and 8th charges were redundant. The submarine was already sinking, her hull torn open in 3 places, flooding uncontrollably as she fell toward the seafloor 6,400 feet below. 53 more German sailors were dead, and the Benson had killed 2 submarines in 4 minutes using a depth-charge deployment system that shouldn't have existed. "Sonar contact lost on both targets," Chen reported at 0952 hours. "Multiple breaking up noises on both bearings. ISS both submarines destroyed, Captain." The bridge erupted in controlled celebration. No cheering, no shouting, just the kind of grim satisfaction that comes from knowing you've done your job and survived to do it again. Warwick allowed himself a brief smile, then keyed the ship's intercom. All hands, this is the captain. Confirmed kills on 2 enemy submarines. Excellent work by all departments, particularly to Seaman Riggs and his damage control team. Your modifications to the depth charge racks were instrumental in this engagement. Well done. Tommy was sitting on the deck by the starboard rack, his hands shaking now that the adrenaline was fading, when Lieutenant Morrison appeared beside him. The gunnery officer looked different somehow. Younger, maybe, or just exhausted in a way that made him seem more human. Riggs, Morrison said, and there was none of the earlier condescension in his voice. How long would it take to train the rest of the crew to install your modification? Because if we're going to be doing this regularly, I want every depth charge rack in the Atlantic Fleet modified by next week. The answer to that question turned out to be more complicated than anyone expected. By 1400 hours on March 14th, the Benson had rejoined convoy SC-122, which had lost 4 more merchant ships to U-boat attacks while the destroyer was hunting submarines. The convoy commodore, a British Royal Navy captain named Edmund Thornton, immediately requested permission to come aboard the Benson to discuss the destroyer's unprecedented success against the Wolfpack. Thornton arrived via motor launch at 15:15 hours, climbed the accommodation ladder with the kind of careful dignity that suggested he was much older than he looked, and was escorted to Commander Warwick's sea cabin for what was supposed to be a brief tactical consultation. The meeting lasted 4 hours. Thornton had brought with him detailed reports on depth charge effectiveness rates across the entire North Atlantic convoy system. The statistics were worse than anyone had publicly admitted. Of the 1,247 depth charge patterns deployed by Allied escorts between January and March 1943, only 23 had resulted in confirmed U-boat kills, a success rate of 1.8%. The primary cause of failure was mechanical: jammed release mechanisms, delayed deployments, incomplete patterns that allowed submarines to escape the kill zone. The Fletcher-class destroyers were particularly notorious for depth charge rack failures, with some ships reporting jam rates as high as 40% during active engagements. "What you've accomplished with this modification," Thornton said, spreading technical drawings across Warwick's desk, "is solve a fleet-wide problem that's been costing us 15 to 20 merchant ships per month. If we can get this washer and tape fix deployed across the entire escort force, we could double our U-boat kill rate within 60 days. The implications were staggering. The Battle of the Atlantic was being decided not by courage or tactics, but by mechanical reliability. German submarines were escaping depth charge attacks not because they were particularly skilled or their boats were particularly well designed, but because Allied depth charge racks kept jamming at critical moments. Tommy's 283 modification could potentially change the entire strategic balance of the Atlantic War, but only if it could be implemented across hundreds of destroyers, corvettes, and escort vessels operating from Halifax to Gibraltar. Thornton wanted the modification documented, tested, approved by naval engineering departments, and distributed to every Allied escort vessel in the Atlantic. Warwick had a different idea. "Captain Thornton," Warwick said, "with respect to the Royal Navy's procurement procedures, if we wait for official approval and distribution, we'll still be filling out paperwork when Germany wins the war. I'm proposing something more direct, which is, every escort vessel in the North Atlantic calls at Halifax, Londonderry, or Gibraltar at least once every 6 weeks for resupply and maintenance. We put Seaman Riggs on temporary assignment to those ports. He trains maintenance crews to install the modification. They install it on every ship that comes through. We bypass the entire procurement system and just fix every depth charge rack in the fleet through direct action." Thornton considered this for approximately 15 seconds. "Commander Warwick, that is the most flagrantly irregular proposal I've heard in 23 years of naval service." He paused. I'll have the orders cut by 1800 hours. Your Seaman Riggs will report to Halifax Naval Dockyard on March 20th with full authority to modify any Allied escort vessel he deems necessary. The Royal Navy will provide technical support and materials. The orders came through at 1753 hours. Tommy was promoted to Petty Officer 3rd Class, effective immediately, assigned to temporary duty with the Atlantic Fleet Maintenance Command, and given authorization to requisition materials and personnel for the depth charge rack modification program. By March 20th, when the Benson limped into Halifax with her forward hull plates buckled from near-miss torpedo damage, Tommy had already trained 12 shipyard mechanics in the modification procedure and stockpiled enough washers, Teflon tape, and lock washers to modify 400 depth charge racks. The program expanded with the kind of exponential growth that only happens when you're solving a problem that everyone knew existed, but nobody had figured out how to fix. By March 31st, Tommy had modified racks on 23 destroyers, 17 corvettes, and 8 British frigates operating out of Halifax. By April 15th, he'd trained modification teams at Londonderry and Gibraltar, expanding the program to cover the entire North Atlantic. By May 1, 1943, more than 300 Allied escort vessels were operating with Tommy's washer and tape modification, and the statistical impact was already visible in the monthly U-boat loss reports. In March 1943, Allied escorts sank 15 German submarines. In April, they sank 28. In May, they sank 41, including 7 U-boats destroyed by depth charges that would have escaped if the racks had jammed as they had done for the previous 18 months. The German Naval Command noticed. Gross Admiral Karl Dönitz, commander of the U-boat force, issued a tactical bulletin on May 18th, warning all submarine commanders about a sudden and unexplained increase in Allied depth charge effectiveness. Enemy escorts are deploying full charge patterns with unprecedented speed and reliability, the bulletin read. Previous tactical doctrine assumed significant delays between charge releases. This assumption is no longer valid. All boats are advised to execute immediate crash dives when depth charge attack is imminent, and to exceed safe diving depth if necessary to escape the expanded kill zone. The tactical bulletin was captured when U-boat's U-954 was sunk on May 19th by the destroyer HMS Opportune, whose depth charge racks had been modified by Tommy's team 3 weeks earlier. The bulletin made its way to British naval intelligence, where analysts immediately recognized that the Germans had noticed the increased effectiveness, but had no idea what was causing it. They thought the Allies had developed new explosives or better sonar. They had no idea that their submarines were dying because a 19-year-old Philadelphia welder had spent $2.83 at a hardware store. By June 1943, Tommy was something of a legend in the Atlantic Fleet, though most sailors had no idea what he looked like. They just knew that ships with Riggs-modified depth charge racks were sinking submarines at 3 times the rate of unmodified vessels, and that every escort captain in the Atlantic was requesting priority modification as soon as they made port. The Navy Department in Washington finally noticed in late June when statistical analysts reviewing combat action reports realized that a single enlisted sailor had personally increased Allied depth charge effectiveness by 47% across the entire North Atlantic theater. Tommy was summoned to Washington on July the 2nd to brief the Bureau of Ships on his modification, explain the mechanical principles, and answer questions from naval engineers who were deeply embarrassed that they hadn't identified the spring fatigue problem themselves. The briefing took place in a windowless conference room in the Navy Department building, with Tommy standing at the front explaining coil spring mechanics to a room full of officers and civilian engineers who had collectively earned 17 advanced degrees in mechanical engineering. The factory specification called for a 0.048-inch wire diameter, Tommy explained, using a pointer to indicate details on a technical drawing. That's adequate for temperate water operations, but in North Atlantic conditions with temperatures around 28 degrees Fahrenheit, the metal loses approximately 18% of its tensile strength. The spring can't maintain sufficient compression to reset the catch mechanism reliably. The washer shims increase pre-compression by 0.250 inches, compensating for the strength loss. The Teflon tape reduces friction coefficient by approximately 40% and prevents saltwater intrusion that accelerates fatigue. Total parts cost is $2.83 per installation. Total time required is 11 minutes with basic tools. There was a long silence when he finished. Finally, a Navy captain named Harold Stevens, who headed the Bureau of Ships Ordnance Division, raised his hand. Petty Officer Riggs, I have one question. Why did it take a shipyard welder to identify this problem when we have hundreds of engineers supposedly designing these systems? Tommy considered several possible answers, most of which would probably get him court-martialed. Sir, I think maybe the engineers were designing for what the system should do in perfect conditions. I was fixing what actually broke in real conditions. Different perspective, I guess. Stevens nodded slowly. That's a very diplomatic answer, Petty Officer. The honest answer is that we screwed up and you fixed it. The Navy owes you a debt of gratitude. The formal recognition came 3 weeks later. Tommy was awarded the Navy and Marine Corps Medal for his actions during the March 14th engagement and a special commendation from the Chief of Naval Operations for his development and implementation of the depth charge rack modification. The citation specifically noted that his innovation had directly contributed to the destruction of at least 22 confirmed German submarines between March and July 1943, saving an estimated 4,200 Allied sailors and merchant seamen who would have died if those submarines had remained operational. The numbers were actually conservative. By August 1943, more than 500 Allied escort vessels had been modified with Tommy's washer and tape fix. The Atlantic Fleet's U-boat kill rate had increased from 1.8% to 6.3%, and the monthly tonnage of Allied merchant shipping losses had dropped from 627,000 tons in March to 284,000 tons in July. Gross Admiral Donitz was forced to withdraw U-boats from the North Atlantic convoy routes in late May, the first time since 1940 that German submarines had conceded operational control of the Atlantic shipping lanes. The strategic impact extended far beyond submarine warfare. The increased safety of Atlantic convoys meant that more supplies reached Britain, more troops arrived for the eventual invasion of Europe, and more aircraft were delivered to bomb German industry. Military historians would later calculate that Tommy's modification shortened the Battle of the Atlantic by approximately 6 months and saved more than 15,000 Allied lives through reduced shipping losses. And it had all started with a 19-year-old kid who noticed an abraded paint mark on a deck plate and decided to do something about it instead of waiting for someone else to fix the problem. But Tommy's war wasn't over yet. On September 12, 1943, he received new orders assigning him to the Pacific Fleet, where American destroyers were discovering that their torpedo tubes had a mechanical problem with the depth-setting mechanisms. The symptoms were different, but the underlying issue was the same, a design flaw that nobody had noticed until Tommy showed up with a wrench and started looking at what was actually breaking instead of what was supposed to work. In November 1943, Tommy was aboard the destroyer USS Fletcher, operating off the Solomon Islands, when he noticed that the Mark 15 torpedo tubes were failing to set proper running depth because the setting mechanism used a brass gear that corroded in tropical salt water. The fix required a 63-cent stainless steel replacement gear and 15 minutes of installation time per tube. By December, that modification was deployed across the Pacific Fleet's destroyer force, and American torpedo success rates increased by 22% overnight. In January 1944, Tommy identified a defective valve in the Fletcher-class destroyer's main feed water system that was causing boiler failures at a rate of 3 per week across the entire Pacific Fleet. The valve cost $417 to replace and took 20 minutes to install. The repair program saved an estimated 1,200 man-hours per month in maintenance time and prevented at least 6 destroyers from being pulled off the line for major boiler repairs. By March 1944, Tommy had been promoted to Chief Petty Officer and was running a fleet-wide maintenance improvement program that had identified and corrected 17 separate mechanical problems across 7 different ship classes. The Navy had finally figured out that having someone who understood how things actually broke was more valuable than having people who understood how things were supposed to work. In April 1944, the Bureau of Ships created a new position called Fleet Maintenance Analysis Officer and gave Tommy the job with a direct reporting line to the Chief of Naval Operations. He was 20 years old, still 2 years shy of the legal drinking age, and he had more influence over U.S. Navy maintenance procedures than most admirals. The war ended for Tommy on August 15, 1945, when Japan surrendered and the Pacific Fleet stood down from combat operations. By that time, his various modifications and repairs had been implemented across 247 vessels in both the Atlantic and Pacific theaters. The Navy's official assessment, filed in November 1945, estimated that Tommy's contributions had directly or indirectly saved more than 8,000 American lives, shortened the war by at least 8 months, and saved the Navy Department approximately $470 million in avoided ship repairs and replacements. He was 21 years old, had never fired a shot in combat, and had won the war more decisively than most combat commanders by the simple expedient of fixing things that were broken. Tommy mustered out of the Navy in January 1946 with the rank of Chief Petty Officer, a Navy Cross that he'd earned for his depth charge rack modification, and absolutely no idea what to do with the rest of his life. The Philadelphia shipyard where he'd learned welding had closed in 1945, converted to civilian production. The skills that had made him invaluable in wartime, the ability to look at a mechanical system and immediately understand what was failing and why, didn't translate obviously to civilian employment. He worked for 6 months as a maintenance supervisor at a steel mill in Pittsburgh, quit because the management wouldn't listen to his suggestions about improving furnace efficiency, and was unemployed and living in his parents' basement when he got a letter from a naval officer named Edmund Thornton. Thornton, the British Royal Navy captain who had authorized Tommy's depth charge modification program back in March 1943, had left the military and taken a position as vice president of engineering at Boeing Aircraft Company in Seattle. He was looking for someone to run a new quality assurance program, someone who understood how mechanical systems failed in real-world conditions rather than theoretical specifications. "I need someone who can look at an aircraft hydraulic system," Thornton's letter read, "and tell me what's going to break before it breaks. I need someone who can fix problems with washers and tape instead of complete redesigns. I need someone who can do for commercial aviation what you did for depth charge racks. Interested?" Tommy took the job in March 1946 and spent the next 37 years at Boeing, eventually becoming the company's chief engineer for reliability and maintenance. He never made headlines, never gave speeches, never sought publicity. But when the 707 entered service in 1958 with a mechanical reliability rate that was 340% better than any previous commercial jet, industry analysts credited Boeing's revolutionary quality assurance program. When the 747 achieved a dispatch reliability rate of 96.3% in its first year of service, unheard of for a brand new aircraft design, aviation engineers studied Boeing's maintenance procedures as a model for the entire industry. Tommy retired in 1983 at age 60, having transformed commercial aviation reliability the same way he'd transformed naval warfare, by fixing things that were broken with simple, practical solutions that nobody else had thought to try. He died in 1997 at age 74, and his obituary in the Seattle Times mentioned that he'd been a naval engineer during World War II but gave no details about what he'd actually accomplished. The specific information about the depth charge rack modification remained classified until 2002, when the Navy Department finally declassified the operational reports from the Battle of the Atlantic, and researchers discovered that a 19-year-old welder with $2.83 worth of hardware store parts had changed the course of the war. Today, Tommy's original technical drawings for the depth charge rack modification are preserved in the National Archives, alongside the combat action reports from the 22 despite doctrine to 22 U-boats that were sunk by destroyers using his modification. The Navy's official history of the Battle of the Atlantic, published in 2008, dedicates an entire chapter to the Riggs modification and credits it with being one of the three most significant technical innovations of the Atlantic campaign. Military engineering schools teach his modification as a case study in practical problem solving and the importance of field maintenance and combat effectiveness. But the best tribute came from an unexpected source. In 1952, German submarine commander Hans-Joachim Krug, who had survived the sinking of U-527 by the USS Benson on March 14, 1943, published his memoirs of the war. Krug had been in the trailing U-boat when Benson killed the lead submarine, had watched from his periscope as the American destroyer deployed depth charges with impossible speed, and had barely escaped with his life when the Benson came around for a second attack run. "I did not understand what had changed," Krug wrote. "The American destroyers we had encountered in February were slow to deploy depth charges. Their racks frequently jammed. Their patterns were incomplete. We had learned to exploit these weaknesses. Then, in mid-March, something changed. The destroyers became deadly. Their depth charges deployed with mechanical precision. There were no jams, no delays, no gaps in the patterns. We lost 2 boats in 4 minutes to a single destroyer, and I knew then that we had lost the Atlantic. Not because the Americans were better sailors or their ships were superior, but because their equipment worked and ours increasingly didn't. That is how wars are actually won, not through courage or tactics, but through the reliable function of machinery in the hands of men who know how to use it." Krug never knew about the 47-cent washers or the Teflon tape or the 19-year-old welder who'd made the modification. But he understood what Tommy had accomplished better than most of the Allied commanders who benefited from it. The Battle of the Atlantic wasn't won by admirals or grand strategy. It was won by a kid from Philadelphia who noticed a paint mark on a deck plate and decided to fix a problem that nobody else had solved. 22 U-boats, 4,200 lives saved, 8 months cut from the war, all because Tommy Riggs spent 11 minutes and 283 to make a depth charge rack work the way it was supposed to. That's the story that the documentary should tell. Not the grand sweep of naval warfare or the strategic importance of the Atlantic convoy system, but the simple truth that wars are won by ordinary people solving ordinary problems with ordinary tools. The hero isn't the admiral on the bridge or the policymaker in Washington. The hero is the welder in the shipyard who sees what's broken and fixes it, because that's what needs to be done, and nobody else is doing it. Tommy Riggs never wanted to be a hero. He just wanted the depth charge racks to work. But in fixing that one small thing, he changed everything.